Now the today's topic is simple harmonic motion. What is simple harmonic motion? When a body repeated its motion after regular time interval, that is called simple harmonic motion. And what is the time period? A body repeated its motion after during the time interval, that is called the time period. And if a body moves through and fro, its motion, that is called oscillations. Simple harmonic motion is a motion in which the particle moves on a fixed point on a straight line, that is called center of oscillation. And acceleration is directly proportional to the displacement. Force is directly proportional to the displacement, and acceleration is always towards the fixed point on a straight line. That means if we calculate acceleration, the acceleration equals to minus omega square x. We know that acceleration equals to force upon mass, then it becomes minus omega square x, that F upon m equals to minus omega square x, at force is minus m omega square x. If we put a constant minus k where k equals to minus m omega square. Here k is spring constant, x is displacement, and F is force. The resulting force is always towards a fixed point, that is x on the center of oscillation. If F equals to 0, that means the particle is at the center of gravity. The particle is at center of oscillations. What is restoring force? A particle moves, a force which backs the particle on the center of gravity, that is called restoring force. Now we take the problem. The resulting force acting on a particle executing simple harmonic motion is 4 Newton, that is F equals to 4 Newton, and it is 5 centimeter away from the center of oscillation. Find the spring constant. 5 centimeter, find the spring constant. The formula used is F equals to minus kx, force is 4 Newton, and distance is 5 centimeter. We convert it into meter, that is 5 into 10 to the power minus 2 meter. Then F k equals to F upon x, 4 Newton upon 5 into 10 to the power minus 2 meter, 4 into 10 to the power 2 upon 5, that is 400 upon 5, equals to 80 Newton per meter. The value of spring constant is 80 Newton per meter. The next topic is equation of motion of a simple harmonic motion. Equation of motion of a simple harmonic motion. Suppose a particle of mass m, small m, moving at v velocity and x displacement at time 0 to time t. Then the acceleration of the particle is a equals to F upon m. We find out force equals to displacement, then put this value into equation 1. A equals to minus k x upon m. Kx upon m equals to minus omega square x. X से x cancel out, then k equals to k upon m equals to m omega square. We can note down omega equals to k upon m and a equals to dv over dt. Then it become dv over dt equals to omega square dv over dx into dx over dt equals to minus m omega square. Then we note dv over dx equals to minus m omega square. dv equals to minus m omega square dx. Now we have to integrate taking limits. v की लिमिट्स हैं v नॉट टू v एंड t 0 to t. v नॉट dv equals to minus m omega square 0 to x naught. Then v square by 2 0 v naught equals to minus m omega square x, here's x square by 2 x to x naught. Then it becomes v square minus v naught square equals to m omega square x square minus x naught. v square equals to v naught square plus m omega square x naught minus m omega square x equals to v naught square plus m omega square x naught minus m omega square x. Then it takes its under root value v naught square plus m square omega square x naught minus m omega square x. Now we take the common in it. V equals to omega under root v naught upon omega plus x naught square minus x square. Let a equals to v naught upon omega plus x naught. Then v equals to omega under root a square minus x square. We put this value into equation 2, that is v equals to omega under root a square minus x square. Then we can note that v equals to dx over dt because displacement upon time. Then the equation will come dx over dt equals to omega under root a square minus x square a square minus x square equals to omega dt. Then we integrate it with respect to t and taking limits x naught to x dx over under root a square minus x square equals to omega 0 to t dt. We know that sin inverse x upon a का फॉर्मूला होता है 1 upon under root a square minus x square. And put this value into the equation of third. Sin inverse x upon a limits हैं x naught to x equals to omega t 0 to t. Then upper limit minus lower limit sin inverse x upon a minus sin inverse x naught upon a, and here omega t. Then sin inverse x upon a is equal to omega t plus sin inverse x naught upon a. Let sin inverse x naught upon a is equal to delta, then the equation becomes sin inverse x upon a is equal to omega t plus delta. Then we calculate the value of x equals to a sin omega t plus delta. This is the equation of displacement of the simple harmonic motion. We take the problem 2. A particle of mass 200 gram executes a simple harmonic motion. The restoring force is provided by a spring constant 80 Newton per meter. Find the time period. M equals to 200 gram and K equals to 80 Newton per meter. Then the formula is used. We find out time period. T equals to 2 pi under root m upon k. T equals to 2 pi under root. This will change into kilogram. 200 into 10 to the power minus 3 kg. Upon 80 Newton per meter. It will cancel out. Then the answer will be 0.31 second. The next topic is frequency and angular frequency. What is frequency? Frequency is basically a number of oscillations per unit time. It is the reciprocal of the time period. Nu equals to 1 upon T 2 pi by omega, that is omega upon 2 pi, or omega equals to 1 upon 2 pi under root k upon m. Here omega is angular frequency and nu is the frequency. The next topic is simple pendulum. Suppose a particle moves through and fro motion then the torque will be mgl sin theta, that is mg into oa sin theta. This is the torque. Torque is not directly proportional to the displacement, is not directly proportional to displacement. Then we find out angular acceleration. Angular acceleration equals to torque upon moment of inertia. Here we calculate the moment of inertia, that is moment of inertia equals to mass into distance square, that is I equals to m into L square. I equals to ml square and torque equals to mgl sin theta. We know that sin theta is very small quantity, that it will be equivalent to only theta. We put this value mgl theta. Now we have to find out the acceleration equals to I mgl theta upon ml square. Cancel out cancel out and l cancel out. Then the formula is alpha equals to g upon l theta, and the time period of simple pendulum equals to 1 upon 2 pi under root g upon l. This is the time period for simple pendulum. We take the problem. Calculate the time period of a simple pendulum of length 1 meter. The acceleration due to gravity at the place is pi square meter. Length 1 meter and acceleration due to gravity is pi square meter per second square. The formula is t equals to 2 pi under root L upon G, t equals to 2 pi under root 1 upon pi square, 2 into pi and into 1 upon pi, pi se pi cancel out, t equals to 2 second.